All right, this is Algebra 2, Lesson 9-9, Graphing Sinusoidal Functions. Today's date is Monday, March 2nd, 2020. This is a re-recording of the video because the first lesson kind of failed in a few regards, and I think I fixed those things. So our objective today is to graph the sine and cosine functions using points on the midline and extrema. All right, so since we're talking about sine and cosine, let's look at the parent functions of sine and cosine. So this graph on the left, I'm just randomly choosing here. Let's choose sine. So y is equal to sine of x. And what does that look like? We might as well say, well, this next one is going to be y is equal to cosine of x. So let's zoom in here and talk about sine. I can zoom in even more. So the main thing, the one thing that I really want you to know about sine is this. It starts at the origin. It starts at 0, 0. That's like the biggest thing. I'll do it in red because it means a lot. 0, 0. That is where it starts. And then it kind of cycles. So by default, both sine and cosine have a period of 2 pi. That means when I start off going this direction, I'll eventually come back, and once I get to 2 pi, I will again be going in that direction. I kind of start the cycle over again. So how do I get from 0 to 2 pi? Well, I go up to pi over 2, and I have the maximum amplitude. Again, the amplitude here is 1. I really have a 1 sine of x, hidden 1 out front. So let's try to sketch this. That means I should come up to this point. I should go down through pi, 0. I should go through 3 pi over 2, -1, and then back to the starting point. So let's actually make those points big on our notes. Those are kind of the important points that you need to have throughout this process. I guess for the first 2 points are the biggest ones. But what does the graph look like when we sketch through those points? So it comes up through this point, has its max, and then it comes down through our midline. Again, our midline is the x-axis in this case. Comes down through our midline. It has its minimum at this trough at 3 pi over 2, and then it comes back up to 2 pi. So that's what our sine function looks like. Those are its points. Main thing starts at the origin. Now let's talk about cosine. So cosine does not start at the origin. It starts at 0, 1. It actually starts at an extreme value, an extrema. This is its maximum, right? So I'll put this in red. It is important. It starts at 0, 1. That's the important bit about cosine. And from there, you should be able to get the rest of it. It kind of has the same pattern as sine, where it's now going to come down. So it's going to come down through pi over 2 for its midline. It's crossing its midline as the second point, whereas the second point over here is hitting its maximum. And that comes down to its minimum in this trough down at pi, -1. Back up through its midline at 3 pi over 2, and then again hitting its maximum at 2 pi, 1. So make sure you have those points, and then do your best attempt to sketch what's going on here. Again, my hint is whenever you sketch these things, use lots of lines. Don't try to have one continuous line, because the continuous line won't look as nice as if you do lots of little pieces. And I guess this one is not looking as nice as my sine graph, but it's whatever. You know, it generally looks like that. And then we have finished the cycle, and then it's going to go down again. And then, of course, I could have gone down again in that direction. It doesn't stop. It continues on and on. It's continuous towards infinity in the positive x direction, towards negative infinity in the negative x direction. Same thing with sine. It goes on forever and ever and ever and ever. It's a sine wave. It waves and waves and waves. All right, so those are our parent functions. You are going to be starting out each of these graphing homework assignments by starting with graphing sine, starting by graphing cosine. So make sure you have those down. Let's talk about the general formula. So our general formula here, we've seen this guy many times now. Let's talk about what each of these letters does. And you should be thinking of them slightly ahead of me in the video. So A stands for amplitude. Amplitude. And I'm going to come back through these and talk about them a little bit more in depth than we did before. Oh, I should mention that this sign could be sine or it could be cosine, so I'll put a cosine up above that. It could be either one of those two for today. We don't really talk about tangent that much. It's not as useful. B, I'll come back to. It's kind of the harder one. K, that's an easier one. So K is the midline. And then B, that's the harder one. It's not, a lot of people will say that's the period, and you're not 100% correct. It affects the period. So right here, it affects the period. How does it affect the period? It affects the period like this, and I'll give you the formula down below, where if I'm looking to find the period, I have to use b, and the way that I use b is I say period is equal to 2 pi divided by whatever b is. And I'm assuming here b is positive. If it's not, then I'd put absolute values. But I think in Khan Academy it's always going to be positive, so I feel safe leaving that just b without no absolute values, without any absolute values. Okay, so coming back a little bit more in depth, if I talk about amplitude, yes, you might see a negative amplitude. You're already probably looking down here like, wait, you said amplitude is always positive. And yes, the amplitude is positive 2, but the equation has a negative 2. So amplitude is always a distance, but you can have a negative value there, so just be warned. I guess amplitude is really the absolute value of whatever this A is. Amplitude, this affects mainly the extremas. So I will write affects y coordinates of extremas. I'll just say ext. I think extremas that's a good abbreviation. It doesn't affect the midline at all. It only affects the extrema, and that's kind of the big point here. And of course, it doesn't affect the x coordinates at all. The period affects the x coordinates of basically all of your points. So you want to think of this as affecting your x coordinates. And not necessarily your y-intercept, though. The x-intercept and the y-intercept is safe. And then for the midline, this is going to affect the midline. So it's kind of redundant to say, but I'll say affects midline. And more importantly, what it does not affect is the, I should say midline, the y-coordinates of the midline. I'm apologizing for that. Should be the y-coordinates of the midline. Got rid of that. Affects y-coordinate. Y-coordinates of the midline. The important piece here that it does not affect, no effect on extrema. And similarly, this A has no effect on the midline. So I'll say over here, no, maybe all caps, no effect on extrema. And I know that I kind of crammed in a lot of information there. I'm going to be going back through that again, but here we go. So here is your general procedure, and I made this up. This is not standard in mathematics. I could do step 1, then 4, then 3, then 2. I did these in the order that makes it easiest as possible, and I think you'll appreciate that. So definitely, like, you always have to start at step 1, I guess, but it doesn't matter from there where you go. So you always want to graph 2 points on the parent function. And usually you want to have a midline point and a point that's on a maximum or a minimum, aka an extrema point. So kind of the big question here is, where are we starting? Are we starting at 0, 0, or are we starting at 0, 1? That's kind of the big question there. And that's for our start values, right? And then from there, graphing the rest of the points correctly. Can you graph all 1, 2, 3, 4, 5 of these points correctly, depending on if it's sine or cosine? Hopefully you have that memorized now, because you're going to be doing it over and over. So number 2, change the x coordinate of the x point, or the, I think that's what I meant. Change the x coordinate of the, the second point. That's what I meant here. Sorry about that. Of the second point, based on the period, or based on, I'll say based on the period. I was going to say based on b, but we know how to get period from b. Based on the period, and then I'll say, like, in parentheses, that's equal to 2 pi over b. I'm going to be kind of redundant over and over again, but let's have very thorough notes this time. Why do I say second point? And the reason it's not the first point, I assume the first point is going to be this one on the x-axis, or sorry, y-axis. This y-axis is safe from moving in terms of the period. The only thing that's going to move this point off of the y-axis is this h thing that we haven't talked about, and I guess I can talk about it really briefly. This is our phase shift, and I'll write this in black. Phase shift. And we don't talk about this guy yet. We will be talking about him later. They just added him on Khan Academy in this last year, so it's kind of cool to actually have an assignment on him. But don't worry about him. H is not coming until, like, another 2 days. For now, it's just those 3 letters. But mainly everything that's going to be on the y-axis is safe today. So it's always going to be moving the x-coordinate of only the second point. Eventually it's going to be first and second point. But for now, the period will only affect second, third, fourth, fifth point, negative first, negative second, but not the 0th point, not the first point, not this y-axis point. I think I'm kicking a dead horse here. So let me move on. Number 3, multiply the heights of the extrema by what value? By this a value. So by a. Notice I'm not saying amplitude. I'm saying a, because amplitude is always positive. We might be multiplying by a negative. So be warned here, you might be flipping your graph over its midline. And then finally, vertical translate by k. By however much k is saying. So if k was 3, then move up 3. If k was negative 5, then move down 5. I think that's all I really want to say about that. Let's move on to example number 1. So I want to graph this function. And on Khan Academy, you have to use one point that is defined by being an extrema, which means, again, if you don't like that word, it's a minimum or it's a maximum. And you also have to have one point that is on the midline. So you'll notice if you drag one point around on Khan Academy, it's only affecting the midline. It'll never turn into a minimum or a maximum. So, Mr. Sindel, why do we have 4 different graphs here? Because there are 4 really key steps in terms of graphing this thing. Last time I tried graphing this all in one graph, and it got really messy, so I want to graph them at each individual step. I'll get more and more complex as time progresses. So the first graph that I want to graph is the parent function. Y equals, in this case, sine, not cosine. So y equals sine of x. And we'll graph that really quickly in a sec. Then I'm going to graph the next one. And where do I have room? I'm going to say this is going to be y is equal to, I think I have room right here. Y is equal to sine of, okay, well, step number 2 is the period. So if I'm including the period, that means I'm going to have some sort of b, some sort of number out front. Okay, the number out front is 1/3. So instead of sine of x, it's sine of 1/3 of x. Okay, that was step number 2. And then here comes step number 3. Step number 3 includes the a out front. So there's the a out front. So I'm doing the same thing, but with that -2 out front. So this is now going to say, I think I'll have room over here. I'm trying to plan it out. Y is equal to -2 sine, I can make my s slightly better, sine of 1/3 of x. And then finally, all of it together, just moving it by that 4th thing, vertical translate, vertical by the way meaning up or down translate by k. And again, if you don't like the word translate, you can think of the word move. So, and that's going to be our final graph, and I'll say, yeah, this is y is equal to, I'm just recopying down this function up here, -2 sine of 1/3 x, and then plus 4. All right, so first, and I should really be making these different colors, so let me color code this. I'm going to make that yellow, let's make that green, let's make that black, so I can distinguish them a little bit easier. Okay, so first with our blue graph, the parent function of sine of x. What does that look like? Let's zoom in here to our graph. We know that sine starts at the origin, at 0, 0. And then from there, I know that it goes, and it has a cycle of 2 pi, so it should come back here, and like if it was moving up to the right here, it'll be moving up to the right here, so it stops its cycle after 2 pi. So I gave you kind of too much of a graph here. So I know that those 2 are points, but this is a point on the midline, and so is that. I don't have any point that's on the extrema, so I kind of need at least one more point. And I know that it's going to go back through the axis, the midline right here, so I'm going to have a point up here at, this is a hidden point, pi over 2 right here, then down through pi comma 0, then back down through here. So our sketch, make sure those points are nice and big, our sketch kind of looks like that. And I'm always going to do, I guess I'll just do a light blue sketch that goes through these points. So that's what our graph looks like after graphing our parent function, just sine of x. And we're going to see how this transforms with each sort of transformation that we're adding in the mix now. All right, so I'm going from here, and I'll do a black arrow that says yes. Okay, now I'm moving to this step. So now I'm going to change the period. Well, how much am I changing the period? Again, our formula says, and I'll do it off to the side notes, I'm working with yellow now, period is equal to 2 pi divided by b. Okay, well, what's b in this case? B is this coefficient out front, so it's 1/3. So I'm changing this b right here to 1/3, and that's equal to 2 pi divided by 1/3. Ooh, nested fractions. Those are always difficult, right? So that's the same thing as 2 pi divided by 1/3. Ooh, okay, so when I do a number divided by a fraction, let's make them both fractions. So I'll add black to say, hey, I'm adding this divided by 1. Now this is a keep it, change it, flip it rule. Whenever you have a fraction divided by a fraction, it's always keep it, change it, flip it. So now this is going to be equal to keep it, 2 pi over 1, change it, multiply instead of divide, and flip it. This is the reciprocal of 1/3, which is 3 over 1. And just multiply straight through. Multiply the numerators. 2 pi times 3 is 6 pi. Multiply the denominators. 1 times 1 is 1, and I can kind of just ignore that. So my period, the time it takes to get to the same point, to cycle through this, is 6 pi. It used to be 2 pi. Look at that. Now it's all the way over here at 6 pi, which is why I gave you so much room. So I'm going to come back over here. Again, it always starts at 0, 0. But now my last point is not going to be at 2 pi. Let's get rid of that. It's going to be at 6 pi. All right, so halfway in between, I know is also going to be on the midline. That's at 3 pi. And then halfway between 0 and 3 pi, well, it's half of 3. That's 1.5. Here's 1 pi. Here's 2 pi. So this right here is 1.5 pi. So I'll make a little tick mark and another tick mark halfway between 3 and 6, which is 4.5. And I haven't changed anything aside from kind of stretching out my numbers. These tick marks are not points, by the way. My point, it used to go, it goes up. So it's going to go up from here, up to an amplitude of 1, and then down to an amplitude down there. So my new function looks like that. Make my points nice and big so you can see them after I sketch my graph. Now my graph looks like this. So it goes through each of these points and make it as curvy as possible to make it still look like a sine wave, and then it starts this process over again and it would go back up and kind of do the same piece that I have right there. So that's what my function looks like. And let's zoom out. All I did is I stretched it out. So whenever this number is less than 1, it's going to stretch out the function. Whenever it's greater than 1, it's going to compress the function. So we stretched it out. Well, now look what I'm doing now. So I'm moving from this function, this graph in the top right, to this graph in the bottom left, and I'm saying, okay, I stretched it out, I still have it stretched out, but now I'm going to multiply all of the heights by -2, and that's exactly what's happening here. I'm multiplying the heights by whatever a is. A in this case is -2, so every single one of these heights, this height, this height, this height, all of these y coordinates are being multiplied by -2. All right, well, this height was 0. 0 times -2 is 0, and I haven't really moved. Okay, so it's still the same point. I haven't moved that point at all. It's kind of the stationary point. What about the next point? I'm looking at this point right here. It had a height of 1, and I multiply that by this number out front, this a value, -2. So this 1 times -2 is -2. So it's still going to come out to 3 pi over 2. It's still going to come out to this tick mark, but instead it's going to go down here to the value of -2. All right, and it's going to still go through the midline at 3 pi. Why? Well, the height at this point is 0. So multiply that height 0 times -2. 0 times -2 is still 0. It does not move. And that's kind of what I was talking about earlier, right? So this was an extrema point right here. This extrema point did move, but these midline points did not move. And that's judging off of that first number. This number right here, it has no effect on the... oh my gosh, did I make that mistake? Oh my gosh, I'm so sorry. Well, if you caught it, log the extra credit. No effect on the midline. Yikes, that was a very bad typo. No effect on the midline. We can very clearly see it does affect the extrema. It only affects the extrema. It only affects the extrema. No effect on the midline. And you can see here, no effect on the midline. These 2 points are exactly the same as they were right up here. The only thing that changed was the extrema. This point affects the extrema. And I'll make a note here also. Extrema. Extrema changed. Changed heights. And the last thing that we need to do, so our height over here was -1 at this 4.5 pi, or you can think of this as 9 pi over 2. So this height was -1. -1 times -2 is +2. So I come back up here to a height of +2 at 4.5 pi. And again, it comes back to the midline, which does not change. This point at 6 pi, 0, 6 pi, 0, the same point. It has no effect on those midline points. Whew. So that was a bit of work, and now we're going to graph it. So make it nice and curvy. Comes up like the sine wave that it is, and then back down. All right, so we're almost there. Now we have our final thing that we need to do. Notice that the difference between the function in the bottom left and the function in the bottom right is just the fact that the bottom right one is adding 4. It's shifting everything up by 4. And that's going to affect all of the heights. And I think I said no effect on extrema y values, or the y coordinates. No effect on extrema x values. Yikes. I'm making mistake after mistake. So no effect on extrema x values. I'm thinking that's kind of pointless and saying, man, I really need to improve these notes for next year, so I apologize. But we didn't really need to say that. Anyway, so this means that everything is shifted up 4. If this was here, it's going to go up 1, 2, 3, 4, and that's its new resting spot. So I come over here, I'm counting up 1, 2, 3, 4. This is its new point, and that's its final resting spot because this is its last graph. This is the full-on graph, right? So I was at a height of -2. I'm going to count up 1, 2, 3, 4. Its new spot is 1.5 pi, 2. So 1.5 pi, 2. All right, the next one was at 3 pi, 0. So I'm going to count up 1, 2, 3, 4, and that's going to be 3 pi, 4. 3 pi, 4. And then finally, the last point was 6 pi. Wait, I'm missing a point. There it is, this point. Second last point is 4.5 pi, 2, this height of 2. And it's going to count up 1, 2, 3, 4 yet again, and it's going to be 4.5 pi, 6. So 4.5 pi, 6. And I realize that this equation is now in the way. I'll move that around later. And then finally, it's going to come back to its final resting spot of 6 pi, 4. How do I know that? Because I count up 1, 2, 3, 4, which is that point right there. All right, so first of all, let me move this equation out of the way. Let's move it, sure, right there. And then I'm going to sketch my line that goes through all these points. So it has to be a sine wave, so it has to be curved throughout the entire process. And done. And again, it continues on and on, so I shouldn't stop it right there. It keeps going on and on and on. But there is our sine wave. And it was a little bit hard to graph, but this process of graphing it segment by segment, transformation by transformation, is how you want to be thinking about these problems. So I realize I've been talking a long time about example number 1. It's time to take a break and then go on to example number 2. All right, example number 2. The same type of thing. First, I'm going to graph the parent function. The parent function this time is cosine. So I'm going to say my parent function is y is equal to cosine of x. Next, we're going to graph what happens when we change the period. That means I'm going to have that pi over 4 on the inside. So this is going to be y is equal to pi over 4. I should have the cosine still in there. Y is equal to cosine of pi over 4x. Next, after that, I'm going to graph what happens if I have that amplitude modifier, so that 5 out front. So this is going to be y is equal to 5, and this, by the way, applies to this bottom graph, not this top graph. Y is equal to 5 cosine of, and it was pi over 4, pi over 4x. And then finally, the entire equation, I just have to subtract 2. So this is going to be in black. Y is equal to 5 cosine of pi over 4x, and then what did I say? Minus 2. Minus 2. All right, we're going to graph each of these in turn and see how it changes from one graph to the next. And right away I notice that, hey, this one has units of pi, this one doesn't. So that means when I move from this graph to this graph, the top left to the top right, I must somehow be getting rid of a pi, and you are correct if you saw that. All right, so how do we do this? Our first question is, what is the starting point? And you should know that if I zoom in here, if I have cosine, cosine always starts at the maximum point at 0, 1, at this point right here. And then from there, it repeats every 2 pi, so its full period will end back here. So I'm going to head down this way, and by the time I get back to this point, I'm going to head down that way to the bottom right. And then I'm going to cross through the x-axis here, and then I'm going to have a minimum point down here. So these are the points that you should have memorized. It kind of looks like a V, right, if I just connect them with straight lines. It is a curve, though. So do your best. Let me make these bigger so it stands out a little bit more. Do your best to make this a curvy cosine wave, and it should look like this. And our minimum looks okay. I guess I'm just better at graphing sine functions. It looks like this one's a little bit off. But there it is. So there's our sketch of our parent function. You should be really good at making those. Of course, these steps, you don't have to do these steps verbatim. These are the steps in your mind that you can be doing, and kind of skip steps. So I might skip that step if I'm really good at graphing cosine, but I'm sure a lot of us need practice at this. All right, so next I'm going to affect the period. I need to figure out what that is. So I'm gonna do some scratch work off to the side. This is our B value, remember? So coming off to the side in yellow, because that's our period. So period, our formula for period is equal to 2 pi divided by whatever that number out front is, 2 pi divided by B. And what is B? We just said it's pi over 4. So this means it's equal to 2 pi all over pi over 4. So how am I going to do that? Well, that's equal to 2 pi divided by pi over 4, and I can treat this as a fraction, so 2 pi over 1. From there, that means I'm going to keep it, change it, flip it, so this is going to be, whoa, what happened there? This is going to be 2 pi over 1. I keep it, I change the division into a multiplication, and I flip it. I take the reciprocal and I get 4 over pi. All right, cool. So I can see a few things that are canceling out right away. I see the pi on the top and the bottom, and that means the 1 is left on the bottom. 2 times 4, I have an 8 in the numerator. And in the denominator, I have 1 times 1, which is 1. Again, I can kind of ignore that. That means it cycles. The entire period happens in every 8 units, which means we got rid of the pi, as we observed before. So we should still have our y-axis, our y-intercept should not have moved. It will never really move until the very last step, until we talk about phase shift. But for now, yes, that's going to be true. Every 8 units is going to repeat, so I repeat back up at that point. Okay, well, halfway in between, we know, should be the minimum, so the minimum should happen right there. And then halfway in between these 2 points, between 0 and 4, which the tick mark is at 2, it should cross this x-axis, which means that's actually a point here at 2, 0. I'm going to try to make all these bigger. And then I should also have a point here at 6, 0. So I slightly stretched out my function. I scaled all of these the same, so that's why these look like rectangles and these look like squares. These are scaled because pi over 2, which is the width of this rectangle, is slightly bigger than 1. It's like 1.5 something, right? All right, and then do your best attempt to make this a nice curvy cosine wave. It just rolls off the tongue, doesn't it? A curvy cosine wave. And then from there, we have our sketch of a graph. All right, so now I'm going to modify this function yet again, this graph yet again, and I'm going to multiply all of the heights by 5. And you can do this a little bit faster. Now this was a height of 1, now it's a height of 5. So come up to 0, 5. There's our height. This had a height of 0. 0 times 5 it's still there at 2. 2, 0. Why does it do that? Let me zoom up, go down. So at 2, 0, and then this had a height of -1. -1 times 5 is -5. So I come down here to -5. And again, the x-coordinates have not changed. It's like every 2 I'm making a point, right? So I go up another 2, or right another 2, and I have a point here, I go right another 2, and I go back up to where I started. If you are uncomfortable with me doing that too fast, you can go back through them one at a time and say, okay, this had a height of 1, 1 times 5, it comes up here to 5, and then do it that way. Anyway, there is our graph. Let's go ahead and make these points slightly bigger so they stand out when we sketch our graph in our notes, and then go ahead and attempt to make a line that looks curvyish that goes through these points. So it comes down, Ooh, not good. Through this point, and oh my gosh, comes through this point at a curvy-ish line. I'm trying. I'm not the best at sketching these. And it comes back, and then it'll start doing it again, but I'm gonna ignore that for now. And it's gonna do it again that way, right? We know that. Okay, finally, we go down to. Every single one of these points goes down to. So this goes down that way, this goes down that way, this goes down that way, and that way, and that way. And you can kind of, oop, too far, that way. All right, so I can do that kind of quickly here. This is gonna go to 0, 3. This is gonna go to 2, -2. This is gonna go to 4, -7. This is going to go to 6, -2, and finally we have 8, 3. 8,3. And then we sketch that graph. And I'm a little bit weirded out. Did I do the period correct? Because I thought I made these the exact size that they needed to be. I said pi over 4, flipped it, it's 8. Yeah, I mean, everything looks good there. So let's zoom in here and try to sketch that line yet again. Ooh, you know what I'm gonna do? I'm unconfident in my abilities. No, growth mindset. It's okay to fail. Failure is good. It's just learning, right? So I'm gonna fail at my drawing, and I'm just gonna get better from here on out. I don't wanna I was thinking about using technology and copy pasting, but I'm just gonna get better the more that I fail at doing this, right? And keep coming up through that point. That's our midline, and comes up through there, and we have our maximum again. Again, if it's not clear, you can see that the midline has been shifted down. I can make a line for these last two graphs. I really had a midline that was right there for that function, and up here it was a little bit harder to see, but our midline used to be here at the x-axis, and then our midline shifted up to 4. Cool. That concludes the notes. I do want to give you one extra piece of advice for those of you watching this video, which is you don't have to do all of these points. Again, you really only need your first 2 points, and you can kind of do all of these steps on one point at a time. For example, if I just follow this point from step 1 to 2 to 3 to 4, and I'm like, okay, well, I've done all 4 steps on it, and I know that that's going to be at the final spot. Graph that one on Khan Academy. And then, for example, follow this point as it undergoes all of its transformations and understand, oh yeah, it's eventually going to go right there. Once you have those 2 points, you are done. You're kind of doing all these transformations in your head, hopefully. Just need one extra arrow that says go from the bottom left to the bottom right, and yeah, so that concludes Algebra 2 lesson 9-9.